everybody, today we are going to solve a problem from Fundamentals of Electric Circuit by Alexander and Sadiku's 5th edition. This is practice problem number 4.8. The question is, using Thevenin's theorem, find the equivalent circuit to the left of the terminals in the circuit, then find I. So we need to find out the Thevenin's equivalent circuit and we have to find out the current I. So it is this current I which is flowing through this load resistance is to be found out. So this is your A and B terminals across which you have to find out. Okay. Now you can draw the equivalent circuit. This is called Thevenin's equivalent, right? So this is your VTH in series with your RTH. That's it. In A and B, across the terminals A and B. So if you have any load resistance, then you can connect it. And in that case, if you are asked to find out some value, IL or I, that also can be found out. Okay. This is the procedure. Now we actually start for finding the value I for 4.8, the practice problem. So here we are going to find out this Thevenin's equivalent circuit. First step is to find out VTH. Second one is to find out this RTH. So in the VTH, it is nothing but this VOC, open circuit voltage across the terminals, that is AB. We can remove this actually. This is not at all actually needed. Open circuit, we want to open circuit it. Okay, so I'll remove this. So across this, you have to find out this VOC, isn't it? This is nothing but your VAB. That's nothing but your VTH. Okay, fine. So if you look into this problem, if you find out the voltage across this 4 ohm resistance, the voltage across 4 ohm resistance will be your VTH. Already this resistance 4 ohm is known, and if you know what is the current which is flowing through this, then product of this I into that resistance will give you this voltage. So we want to find out this current that is flowing through this. So actually we don't know what current is flowing, but we need to find out. So you can go for two methods. One is by applying Kirchhoff's voltage law, or you can apply Kirchhoff's current law. In that case, I prefer only KCL. So it is coming under this nodal analysis. Kirchhoff's current law. What it is, it states that summation of incoming current in a particular node is equal to the summation of leaving current in that. So we can select now the nodes. So this is your first node and this is your second node, and this can be taken your ground node with the zero potential. So this potential can be assumed as V1 potential and this can be taken as V2 potential. And we can assume the current directions here for the branches. And I can mark this as I1 current which is flowing through this particular branch of 6 ohm resistance. And already this current is given in the problem itself which is entering into this node. And we can assume current which is leaving particular first node through the 6 ohm resistance as I2 current. Okay. So if you look at this, that I2 current is entering into the second node which is having the potential V2, and the same current will be flowing through this 4 ohm resistance also because it has no other path to move. So if you want to find out VTH, that is nothing but the resistance 4 into the current I2. So you need to find out this current I2 here. So first we take node 1. So in that particular node, 3 currents are actually flowing, right? The first current I1 that is entering. So entering current I1. Again, the 2 ampere current is also entering. So it is plus 2. But that I2 current is leaving. So here the leaving current I2. Summation of these two are the entering current and this one is the leaving current, isn't it? That is our KCL. So we have applied KCL in first node. After applying KCL, we have to apply Ohm's law here. So that is coming under nodal analysis. If you are very much familiar with this nodal analysis, then you will know that we are applying Ohm's law here. At this point, what is the voltage available? This 12 volt will be available at here also. So Ohm's law means it is V is equal to IR, isn't it? Or we can write I as V by R, where V is the potential difference. So in the same way for I1, we have to write the potential difference as this 12 minus V1 because the current is flowing from higher potential to the lower potential. So it is 12 minus V1 divided by that resistance is 6 ohm. Like that we have to write. 2 amps is already available, so no need to apply anything there. Then, so what is I2 here? When you apply Ohm's law, it is the potential difference. This V1 minus this V2 divided by this 6 ohm resistance. So it is V1 minus V2 divided by that 6 ohm resistance. So that can be applied here for this first equation. I1 is 12 minus V1 by 6 plus this 2, that is equal to I2. I2 is what? This V1 minus V2 by 6. Take the common denominator here. So it is 6. 12 minus V1 plus it is 12, isn't it? That is equal to 6 V1 minus V2. So you can cancel out these two. So you will be getting this as equal to 24. 12 plus 12, that is 24 minus V1. I am bringing this V1 and V2 here. So it becomes minus V1 plus V2, that is equal to 0. So minus 2 V1 plus V2, that is equal to minus 24. So this is your second equation in here. So there is no need to apply KCL at node 2. So simply if you look at this second node, there this V2 voltage is available. That V2 is nothing but the voltage across this 4 ohm resistance, isn't it? So you can write it as that I2 current multiplied by the 4. So it is 4I2. So if you know this I2 value, then you can go for this V2. So you can take this as equation number 3. I can substitute for I2. What is I2? Actually, it is the current which is flowing between this V1 and V2 nodes. That is first and second node, isn't it? So I can apply Ohm's law here. That is 4 into, you can write it as V1 minus V2 divided by 6. So you get some equation here. It is 2, it is 3. So 3V2, that is equal to 2V1 minus 2V2. That means 5V2, that is equal to 2V1. Right? V1 is equal to 5 by 2V2. This is your fourth equation. Into the second equation, you can substitute the fourth equation. What is your fourth equation? V1 is equal to 5 by 2 V2, isn't it? This is your fourth equation. Now substitute this fourth equation in equation number 2. So what do you get? Minus 2 into that V1 is 5 by 2 V2 plus V2, that is equal to minus 24. So this 2 get cancelled out. So you get this as minus 5 V2 plus V2, that is equal to minus 24. Or it is minus 4 V2, that is equal to minus 24. So V2 is equal to 24 by 4, that is 6. So you get this V2 as 6 volts. So it's a very important answer, right? Because this V2 is nothing but your VOC, that is nothing but your VAB, that is nothing but your VThevenin. So we got one answer now. VThevenin as 6 volts. This is one answer. For this given circuit, we need to find out RThevenin. So for that, actually, we need to remove this, right? That should be removed. And you have to kill sources, that means independent sources. That means voltage source should be replaced by short circuit, isn't it? So what is the meaning of that? You have to make a short circuit here. Okay, this is your short circuit. And what about this current source? It's also independent, right? So current source must be open circuited. So it should be open simply at this point. So opening this is actually nothing but leaving this particular branch itself. So you get this much very simplified circuit, and you will get this RThevenin by looking into this equivalent resistance. So we start from here. In this, these two will be your series resistance. These are in series. So if you know that these two are in series, simply you add them so that you get the resistance as 12 ohms. So you will get a new modified circuit that can be drawn like this. This is your modified one. Now this is 12 ohms that is obtained because of this two series resistances. Again here you have this 4 ohm resistance. Then you have this, right? A and B terminals, across which you need to find out the Thevenin. So if you now look at this 12 ohm and this 4 ohm, these two resistors are actually in parallel. How do you actually say that they are in parallel? This is 1 ohm of this 12 ohm resistance. This is another ohm, right? And this ohm is connected to this next end, right? That's how actually we find out. So this is the first ohm of this 12 ohm resistance. This is the second ohm of this 12 ohm resistance. For the same, this is the first ohm of this 4 ohm resistance and this is the second ohm of this 4 ohm resistance. So anyhow, these two are tied together and similarly this first and second are tied together. So when 2 ohms of the resistances are connected together, then we say that they are in parallel. That is the concept. Okay. So when you have this parallel thing, the parallel resistors, how do you find out the equivalent? So it is 12 into 4 divided by 12 plus 4. Okay. If you have the series value, simply you add them, right? For parallel, you have to find out the equivalent like this. 12 into 4 divided by 12 plus 4. So that is 48 divided by 16. So that is equal to 3 ohms. So your RThevenin is 3 ohms. That's it. So you have your second answer. So once you get the two answers, now you go for the equivalent circuit. So what is your VThevenin? It is 6 volts. Then here you have your RThevenin. So what is the value of RThevenin? It is 3 ohms. Then they are connected to this terminals A and B. This is actually equivalent circuit, right? This is your Thevenin's equivalent circuit. But the thing is, we need to find out the current which is flowing through this. That current is given here as I. This is your load resistance and that value is already given in the problem as 1 ohm. Now on that case, simply you can apply any simple formula or anything, you can apply. You can, if you want, you can apply KCL, or if you want directly, you can go for what it is, V by R. Okay, because the total resistance in this circuit now, what it is, total resistance here is this R Thevenin value plus this RL value, isn't it? So it is 4 ohms. So if you want to find out this current I, it is nothing but this VTH divided by the total resistance of that circuit. So it is 6 divided by 4. So what's the value here? It is 1.5 amps. The I current is 1.5. So this is what the answer we actually, final answer we need, right? Hope you have understood. Thank you.